In this video, we're going to talk about forecasting because forecasting is one of the most important things that you do as an operations management manager. And what we're looking at here is time series forecasting. Time series says that we think that something that has happened in the past will continue on in the future in some way. With these forecasts, what we know is that our forecasts that we make, most of the time they're going to be wrong, okay? And we need to determine how wrong they are, because the goal of forecasting is to minimize this deviation between our forecast and what actually occurs. So with this, we normally take an item and look at several different forecasting techniques and see which forecasting technique works the best for that particular item. Once we've done that, we are going to look at how much our forecast deviated from the actual, and then choose that forecasting technique that gives us the least amount of deviation. The case that we have on this exercise is we have actual sales on a monthly basis for 15 months. Okay, so again, we have 15 months worth of data. What we can do from this 15 months of data is we can take and partition it. Partition it into data that we're going to use, which I have put in yellow, and data that we are going to compare it to with our forecasts. Again, I'm going to take the first 12 months and forecast the values for the next 3 months. And what I'm going to be able to do whenever I go through this is, if I forecast the January 21, February 21, and March of 21, and I already know in my back pocket what actually happened, I can compare the forecast to the actual and determine the deviation, so I can look at how each of these different forecasts is operating. So from that regard, let's start with all forecasts by taking, let's take a look at it. I'm highlighting, left click drag, insert a scatter plot, and it shows that from this time period of January of 20 all the way up through December of 20, it looks like we may have a little bit of a downward slope. However, we never go above 35 and we never go below 25. So we're kind of bouncing around in between here. So that kind of gives us a feeling for if I have any forecasts that are below 25 or above 35, probably tells me I need to look at my math, because something's probably not right here. All right, I'm going to get rid of that graph. Now let's take the simplest of the forecasting techniques. Those are what we call moving averages. Moving averages say, in the future, I'm going to base the forecast in the future based on the average of what happened in a time period before. I'm going to copy these for now, bring them back across. This is going to be my final answer. This is going to be what I'm going to call my work area. Okay. A 1 month moving average says if I want to forecast what's going to happen in January, 1 month moving average says I want to take an average of the previous 1 month, all right, which is really just the actual from the month before. Let me say that again. It's also called a naive forecast. It says I expect what happens in January to be exactly what happened in December, which also means that I expect in February for it to be exactly what it was in January. All right? I expect for March to be exactly what it was in February. All right, so that's a 1 month moving average. Next is a moving average for 2 months. So if I type in equals average and look at the 2 previous months before January, again, I'm trying to forecast January 21, equals average of these two, it comes up with 31.5. All right. This brings us to a point in our being practical. Mathematically, 31.5 is the correct answer for a 2 month moving average. However, what we also have is that it doesn't make sense for me to go tell the boss that I'm projecting demand for January to be 31.5. Demand is normally in whole numbers, right? You don't buy 31.5 cars. You have to come up with a system for either rounding it up, to that next higher number, which is what a lot of companies do. They say regardless of the decimal point, if it is 31.1, you would really need at least 32 on the lot if you were selling 31.1. So one way is to round up. Another common idea is just to use regular rounding techniques, which is you round up at 0.5, you round down if it's 0.49 or below. So over here, I'm going to put my rounded numbers. Okay, 30, 27, 30, and I'm typing them in here because I want to make sure that the formulas don't follow me in the future. For this one, I am going to use the technique of simple rounding where it goes up at 0.5. So that would be 0.2. I also know that with my formula, one thing that Excel will do for me is if I right-click on this little box on the bottom, if I left-click and drag across, it will take the formulas right there with it, okay, and moves them forward. So again, this is 29. This would be 29. 3 months moving average equals average. The 3 months before January, 1, 2, 3. I'm going to drag these across. That means 31, 30, 29. Your company may use 6-month moving average. It may use a 12-month moving average, okay? And the whole point is that every time we move forward, and the reason we call it a moving average is that every time we go to that next period, you see that our averages, they move forward by 1 month, okay? So that's why we call it a moving average. Next one that we have is an exponential smoothing. Exponential smoothing is nothing more than a weighted average, okay? So exponential smoothing of 0.2 says that I want 20% of my forecast equals 0.2 to be what actually happened in the previous month before. So if I take equals 0.2 times what actually happened in December, and I add that to what's remaining, okay, which is 1 minus 0.2, right, from a weighted average. So 0.8 times what my previous forecast was. Again, my alpha is what I often refer to in exponential smoothing, is multiplied times the actual. 1 minus alpha is multiplied by the forecast. I cannot extend that across. And the reason I can't extend it across is I don't have a forecast now in for these values, right? So what would be once I have done this forecast for exponential smoothing, I'm going to write 28 here, which is my new forecast, correct? All right, now it means that I need to change my, since I have a new alpha, a new forecast, that would be up here. Now if I click on this and drag across 1, go here, it's saying take 0.2 times what actually happened, 0.8 times my forecast. So again, 28. I'll type that in here. And then I'll drag it one more time, left click and drag, and again, 28 here. I'm going to get rid of these because we're about to do exponential smoothing for 0.4. So don't worry about what happened on these numbers. We captured it here. 0.4 says I'm taking 0.4 times what actually happened plus 1 minus 0.4, which is 0.6, times the forecast. So now we have 29. Let's drag it across. 28. And 29. Get rid of these. Hopefully you get the point so that you can go ahead and do the next one. However, just to make sure we get it right, 0.6 times, again, exponential smoothing, alpha is 0.6, 0.6 times the actual, plus 1 minus 0.6, which is 0.4 times the forecast, 29. $28. Ooh. I forgot to write 28 up here, so my forecast didn't work out right. And then 29. All right, last thing that we're going to do is we need to do a linear regression. You can do linear regression with the information that you have here. If you highlight it, you insert scatter plot, insert that, and then right click on any one of these data fields. It will let you add a trend line. And in that trend line, we want to keep this as a linear regression. We want to display the equation on this chart, and we do to display the R-squared value. Okay, I'm going to pull this up. And again, a linear regression says I'm going to forecast future sales, Y, based on the time period, which is a minus 0.0081. So it's a negative slope plus an intercept, and my R-squared is 0.0757. Again, on the R-squared, what that means is how much variance in time, how much variance in the demand is actually related to time. This, if you multiply times 100%, says that 7.6% of the variance in demand is really based on time alone. Again, not a very high percentage, but it doesn't matter. Excel will do it for you, and then you can decide whether or not you want to use linear regression. Typically, I don't use a linear regression if my R-squared is less than 0.25, because with 0.25 it says 25% of the variance in my demand is really explained by the time. I mean, 75% of the variance is based on other things. So again, linear regression I don't normally use unless I can get at least to an R-squared of 0.25. The problem that I have now is I need to substitute in X, which is this date down below, so that I can come up with a forecast for the month before. Again, I don't know in Excel how this has come up with a number. I don't know how it converted January of 20 to a number. So let me just take this. I'm gonna pull this. I'm gonna pull this down. I'm gonna pull this down and out of the way. Let's take our information here. I'm going to drag it down a little bit too. And instead of using the month, let's switch this over to something that makes sense to me. This is time period 1. This is time period 2, 3, 4. Let's drag this forward. Okay. Now, this is month. And if I take now and put in insert, it looks very similar, right? I mean, it's the same pattern. If I right click, add a trend line, make sure it's linear. I want the equation and the R-squared. One thing that should jump out at us is that, our R-squared is almost identical, but the formula is a bit different. Matter of fact, the formula is that Y is my sales equals minus 0.2483 times the month plus 33.53. So if I want to forecast the 13th month, that would be equals minus 0.2483 times the next month is 13, correct? And then I need to add my intercept. And so my forecast using linear regression would be 30.3. And whenever I round that, it now becomes 30. All right? For you, for linear regression, to forecast February, you would do the exact same thing using all 13 months. And if you were going to forecast for March, you would do linear regression, you would use all of them, do exactly what I just did, okay? That will give you the last items. I'm going to put it in here. I've already done these, and these are the forecasts that come out. And now the last part that we're doing with our forecasting is we're trying to determine which of these forecasting techniques would have been the best, all right? So we want the mean absolute deviation, which means that I want the absolute value difference between what my forecast is and what the actual was. All right? And then I'm going to do my average equals the average of these. So the average amount that I was wrong using the 1 month moving average was I was off by about 2.7 items each time. Okay. You need to now go back through and calculate the MAD for each one of these other items after you put it in there. And what we're looking for at the very end, we want the forecasting technique which has the lowest average deviation over the 3 months that you have just forecast. All right? Hopefully this makes sense to you. Hopefully this gets you going in a good direction. Good luck on this exercise, and I look forward to seeing your results.